Okay, Dr. Smith here. It's time for some physics review. We're looking at Gauss's law, electric potential and capacitance review, the worksheet that came out, Thursday? No, not Thursday, Tuesday. The other day begins with T. All right, so problem one, we're going to start there. That is the problem where the Emperor decides he wants to electrocute Luke Skywalker. So here's the Emperor, I'm evil, blah, blah, and then Vader's over here with his lightsaber. I won't draw much of Vader, okay? And then Luke is on the ground, and he's like, oh my god, help me, okay. So, now that we have the sound effects down properly, the Emperor is able to use the dark side of the Force to change his voltage to negative 300 volts, while Luke has a voltage of 0 volts. And what happens is the Emperor transfers some electrons from himself to Luke. And the Emperor transfers how many electrons? Let's see, Emperor transfers 6 times 10 to the 15th electrons. Is that? Yeah, okay. Electrons go from the Emperor to Luke. Okay, I'm going to call this N, and I'm going to say the Emperor's voltage is, I'm going to call that V, and I'm going to just sort of say Luke is 0 volts, okay? So this is just by way of sort of getting a, don't kill Luke's head. This is just sort of by way of getting some symbolic things on here. Okay, so what's important here, the question is how much thermal energy does Luke acquire when the electrons reach him? Now what really happens is the electrons start at the Emperor and they move to Luke, and their potential energy changes, and it changes into kinetic energy, and then the kinetic energy, that's not drawing, the kinetic energy turns into thermal energy when it reaches Luke and hits him. He's being bombarded, I suppose, by these high kinetic energy electrons, and when they smack into his body, they excite the molecules in them, and it's caused the molecules in his body to go into random vibrations. So that's really what I'm talking about here. Maybe I should have worded the problem a little differently, but that's the idea. So where does this kinetic energy come from? Well, originally it comes from potential energy, electrostatic potential energy from the Emperor. So if the Emperor has a negative voltage, that means he must have, probably he has a sort of a negative concentration of charge compared to Luke, who we presume is sort of neutral. But the point to remember is that lower voltage things tend to have more negative charge. So the Emperor's got a negative charge, which means the electrons he shoots out of his fingers are repelled by him, and they go smashing into Luke because they're being pushed by the electrostatic repulsion force between the Emperor and the electrons. They get smashed into Luke. That's where they pick the kinetic energy up from. And that is energy that was potential energy, electrostatic potential energy, but it got turned into kinetic energy. So really the answer is that I'm going to just calculate the kinetic energy of all these electrons that hit Luke, and that's going to be our answer, okay? So the kinetic energy of all these electrons that hit Luke is what we want to know. We want to know the final one. And really what we want to look for is the change. We sort of assume they start here with 0 kinetic energy and they smack into Luke with some high kinetic energy. So we'll look at the change of kinetic energy, and that is going to equal probably a better way to put it is that since the only force we have acting is this electrostatic force, the change in kinetic energy plus the change in potential energy will equal 0. So we get conservation of total energy. So change in kinetic energy is K final minus K initial, okay, plus, and then what's the change in electrostatic potential energy? Like I said, that's really the only kind of force we have. And the change in electrostatic potential energy, this is a good one to know for the test. Delta U electrostatic energy is equal to, when you have a charge moving through a voltage change, and the voltage change is constant, and we sort of assume the Emperor can hold himself at negative 300 volts constantly, then it's the total charge that moves times the change in voltage. So this is going to be Q delta V, okay? And so what do we know down here? Let's see. First of all, initial kinetic energy is 0. So really this is just K final. So K final and this is really our answer here. K final is going to equal, oh, I'm sorry, this has to equal 0. So then this must equal negative Q times the change in voltage. And we're talking about the change in voltage the electrons go through. So the electrons start at the emperor, who has minus 300 volts, okay, right there, and they end at Luke, who has 0 volts potential. So this is negative Q then times final voltage, so V Luke minus initial voltage, which is V emperor, okay? Trust me, that says emperor. Okay, so K final equals negative. Now this charge here, it's time to start plugging things in almost. The charge here is the total charge of all the electrons that move. So I said, just to keep it symbolic so I don't have to write this stuff out again, I said N is our number of electrons. So we have N electrons times the charge on an individual electron. And an individual electron has a charge of negative E. Important to remember that E is the elementary charge, and that the value of that we'll get to in a second, but it's something you'll be given on a test, I hope. Well, yes, you will. I know, because I read the tests. Well, Mr. Whatever, what am I talking about? Okay, so the charge on an electron is negative E, and you have N electrons. So this is the total charge. This here is the total charge on all the electrons. And then Luke's voltage is 0, and the emperor's voltage is negative. Well, I guess I'm still keeping this constant, right? But I'm trying to keep this symbolic. I plugged in 0 for Luke's voltage. Whatever, okay? V emp. Dang it. Okay, so now let's take all our negative signs. Negative, 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 which means that comes out to be negative. And uh-oh, what did I do wrong? And oh, right. No, we're all good. Okay, because the emperor has a negative voltage. So the final kinetic energy is negative number of electrons times E times the emperor's voltage. Okay? Which is then, I'm going to just pick a different color for plugging numbers in because I feel like it. Okay, 6 times 10 to the 15. I'm going to write 6E15. I hope we've all gotten to use that notation in WebAssign. The charge on the elementary charge, so 1.6 E minus 19 coulombs, right? And then the voltage of the emperor, which is negative 300 volts. Okay, and what this comes out to is, I'm just going to do it up here, okay? K final equals, let's see, oh boy. So the E15, E19, E minus 19, so E minus 4, and then we can do 1.8. So it's 1.8 times 1.6, and that's all E minus 1, I'm pretty sure. Yeah. And so 1.8 times 1.6, 48, 14. Oh crap, what am I doing wrong? 8 times, am I doing this right? Yeah, 8